Moving to the module 3 of our course, it mainly involves in the discussion of the basic instructions and commands that are used in simulation of the programs indulged in the course referred as signals and systems. Here we are about to see what are the basic instructions that are most frequently and oftenly used in the programming language for the particular application of signals and systems. What are the working process of the every instruction and command there, how they work, what are they? As we have already discussed that MATLAB, which stands for Matrix Laboratory, is a state-of-the-art mathematical software package, as it deals with the matrices. It works on both rows and columns, arranging them in a format of a matrix. Once again, let me repeat the point that MATLAB is case sensitive. Means if we have given any program with some instruction as a capital letter or a small case letter, lowercase letter, it should be as it is to be followed throughout the program. And keep it in mind, small a plus capital B is not as the same as small a plus small b operation. This is what it case sensitive means. Let me go into the each and every command what are most commonly utilized. Very first, the very first command used is the plot. Most frequently used, plot x comma y. The main purpose of the function plot is to create a 2D line plot, means a graphical representation of the given data in the form of matrices and arranged in the form of matrices in the terms y versus its corresponding values of x. It is used to create a graphical representation of some data, and it is very often used to see how the trend is carried out in the data when plotted. Whenever we feel the difficulty in identifying, just looking at the raw numbers, we cannot justify how the input and output values are varying with respect to each other. This is how we use the plot comma x comma y, plot of x comma y function to form a 2D line plot of the data, which is plot between y and x, means y versus the corresponding values in the x. Next one is subplot. It can be called as a sub of the plot as said earlier. Now, subplot of m comma n comma p. Most of the times it is used in the same format in the MATLAB also. The main purpose of this instruction is to divide the entire picture or figure into an m by n grid. Look at that m n values there, m by n grid, and creates axis in the position specified by p. Means MATLAB numbers its subplot positions by row. Means the first subplot is the first column of the first row, the second subplot is the second column of the first row, and so on. Like this, it is going to be carried out. Let me clear once again. Subplot of, if we give the values 3, 1, and 2 there, 3, 1, 2, it is 3/1 grid in the axis of 2. Position number 2. P represents the position here. Keep it in mind. Now, in simple words, a subplot is a secondary strand of the plot. As I said, plot in the beginning, secondary strand. Now, it is just like a supporting side story of the main plot. Now, the subplots tend to connect the main diagrams with respect to the given values in the so-called programming part. Moving towards the next most frequently used is stem. This is mainly useful for plotting the data whatever has come in discrete. Means discrete data sequence is plot for y at value specified by x. Just it is, we can say it is what you call an analogous one or discrete form of the plot given in the very first as a first instruction. It acts as plots the data sequence y as the stems that extend from a stems. Whenever you see the how the graph is plot is, it is in the form of stems that extend from a baseline along the x-axis. At the top, the data lines are indicated by circles here. We will see this one in the next module when we do one example for generation of sequences, how the stem it is utilized. And the next one, the title. As I already said in the previous module, that MATLAB utilizes very natural notations while coming to programming part, in irrespective of what type of application we are using. Means in other programming languages, we have like a bunch of lines to even generate a simple graph. But here in MATLAB, we use a very natural notations. Natural notations means, once again, I like to clear here, generic words which we use in our daily language, daily day-to-day language. What are the terms we use? They are going to be utilized here in the MATLAB commands. The title itself, within the bracket, it is some text, whatever may be text here. For example, I can put down some text here. It must be quoted in a single quotes. Keep it in mind, it must be quoted in single quotes. It has been not given here, but it must be quoted in single quotes, the title text. Here, it gives a value, the name, whatever the title text is given, that is going to be added or specified to the access or that standard visualization. In simple words, I can say that this particular command helps to provide the name of the so-called particular block we are using can be specified there by its name. That's why it is called as title. This is one part. This title, once again repeating, title of, it must be in single quotations. Next command is once. Most used in the signals and systems is once. What is once? Here, it create arrays of all one values. That is once unity. In other terms, we can say. Means, for example, if I write ones of n, it returns an n by n matrix of ones, one values. For example, if you write ones of m n here, it returns m by n matrix of ones. It goes on like that. Just an example has given here. Ones means it creates ones. Similarly, on the similar note of ones, the next command, which is referred as zeros, it returns an n by n matrix of zeros. These particular ones and zeros are most used in representation of the type of the signals where we utilize, for example, unit step equals to 0 and 1, where the 1 value lies and where the 0 value lies. Like that, in those type of signals, it is very utilized. Why I am saying here, it is in the entire matrix laboratory, whatever the input is given, it is considered as a matrix only in the form of a row to the column. Next instruction, which is most preferably used here, is figure. Sometimes it is given figure of some number there. It says that it creates a figure for the graphical object that, or to the particular window that has been popped up after execution of some program. In the program, if we don't mention figure, also, the plot and subplot, the plot, subplot, stem will also give us the windows. But if there are multiple figures are available in a particular program, then the confusion must be solved by having figure of 1, figure of 2, figure of 3, so on up to how many figures I am going to plot and pop up in the form of a new window. I shall give it the number. Then only we can clearly differentiate between one window of the figure to the another window of the figure. That is why the figure is most frequently utilized in MATLAB programming language. Next one, X label, as the name gives, label. It labels means it gives the names, gives the name of the current axis for the purpose of visualization. It is similar terms Y label of text. It labels the Y axis, labeling the axis there. Whatever the text we give in the bracket there, txt, that text will appear in that particular figure window as y-axis on the y-axis. Similarly for on the x-axis. This is how these two commands, X label and Y label, work on. Next one, which is preferably used in the beginning of the program most of the times, is input. That input command is used to display the prompt where we have to give the input. Just like we have the prompt command in C programming language, here we have a command window. It will go to that command window and it will ask us to, or prompts the user to provide the input value for what, and then we have to press the return key. Return key means once we press the enter key here, it goes back to the execution. Now input functions take an arbitrary data source, in memory data sets, streaming data, whatever the type of data we are going to give here, it takes that command particular takes whatever the value we give there, and this input value will differ from one value to the another value. Here once again let me tell that it displays the text in prompt and waits for the user. You will get a command that it is wait, like that you will see there. Next, the next one is grid on. As the name suggests, grid on, it displays the grid lines in the entire plot, that is in the entire axis. For the entire, that is axis means X and Y, grid lines connecting to each other, such that it grid, in the same terminology, we can also mention grid space OFF off. It is mainly used for the removal of all the grid lines from the current axis. What happens here? The grid, whatever the grid has been generated here, it helps us for the visibility of the grid lines, and also this grids will help us to differentiate and to identify the values on the waveforms in a clear manner. Means if there are decimated values like 2.2, 3.2, like that, 4.1, like that, if values are there, those values can be clearly and legibly, they can be observed by the particular command after having the grids there. Similarly, other than these commands, there is one more command called as hold on. This hold on retains the plot in the current axis. And other than these instructions and commands that has been provided here, there are some more commands which are very equal to C programming language. Before discussing all those things, let me take you to the how the MATLAB window looks like in our course, which type of version we are utilizing in our course. Let me show you that window here. This is the window that is going to be utilized in the our course. You can look at the top: home, plots, apps, editor, publish, view. Here, other than that, you can see at the bottom there, command window. At the left corner, you can see current folder. In the middle, you can see editor. I will explain you what happens at each and every point. Command window is same as of, you can see the two cursors, two arrow marks there. Fx is represented there. Fx is represented there. Fx is represented there. You can see this. Here, it indicates the prompt as in the C programming language. Similar to that of C programming language, here we see the editor window. Here is the place where we enter the programming part of the particular specific application. And it is the current folder. Whatever the program which is typed down in the editor window, it is going to be saved with some name here into this one. And the extension of the C programming, the MATLAB programming language is similar to C programming language. In C programming language, we use .c. Here we use .m. That program will come to this current folder on the left corner. Now, when we execute, if there are errors, that errors will be showed down in this command window down there. This is how we are able to identify the input, how we are going to do input. Now, here at the top one, we have the new here, option new, open, save, and the run option here. When the program is complete, we go for this run option for debug. We will explain all these things, what are available or visible on the screen while performing one or two programs in the next module of our course.